You've joined a masterclass as a little introduction to the School of Management at the University of Bath. My name is Dr Lancaster, and as Director of Studies for the Exec MBA programme, it's my huge pleasure to welcome you to this session. It's lunchtime here in the UK, but we appreciate some of you are joining from other parts of the globe in different time zones and with different weather. But wherever you are, I think you're in for an enjoyable and instructive session. On your screen is the running order, which I don't think needs much explanation. So following my short introduction, the main event is the masterclass itself, which we expect to run for just under an hour. And a little like some of the lectures you can expect if and when you join the School of Management, Dr Lukasz Piwek will be expanding our knowledge of machine learning, digital traces, and the future of analytics. So following what promises to be a fascinating session, we'll briefly explain some aspects of the MBA and MSc programs to further whet your appetites. And there'll be plenty of time at the end for questions about the masterclass topic and/or about the programs themselves. And on that note, your microphone is automatically muted only because too many voices online get very confusing. So please use the Q&A box at any point through these sessions to comment, to ask questions, to seek clarification, or to express your point of view. We'll come to them at the end. If we do run out of time and have any unanswered questions, we'll try to get back to you by email as may be appropriate. Dr Lukasz is a lecturer, assistant professor in data science here at the University of Bath. And during his illustrious time with us, he has been responsible for co-founding the Interdisciplinary Psychology Sensor Lab and taken the position of associate researcher for an ESRC-funded Centre for Research and Evidence on Security Threats, very pertinent in this age. His research focuses on using data obtained from mobile devices, from smart wearables, from apps, from social networks in user profiling, behaviour change, and developing new digital methodologies. And his projects range from investigating psychological markers of digital footprints, developing novel data visualization techniques, and behavioural analytics with application in healthcare innovation and cybersecurity. So he's perfectly placed to enlighten us about machine learning, digital traces, and the future of analytics. Just before we hand over to Dr. Lukasz, allow me to introduce our other two speakers today. So at the end of the formal masterclass bits, Dee Mahil will be talking about life in Bath and, of course, the Master of Science, the MSc programs. And that will be followed by Professor Steve Wyatt, who will be talking to us about the various MBA programs on offer, the exec and the full-time. In the coming couple of days, everyone who's registered and attended will receive some correspondence from us, including our contact details, relevant information about the program you're interested in, a link to the recording of the event so you can go back over salient parts if you'd like, and we'll ask a small favour through a feedback survey. It really helps us if you can compile and return this survey so that we can evaluate and improve these events in future. But without any further ado, I ask you please to welcome Dr. Lukasz Piwek.
Thank you very much for the introduction, Donald, and welcome everyone. Good afternoon, in fact, not good morning, to this session on machine learning, digital traces, and the future of analytics. As Donald introduced myself, I guess I can actually skip this step here. The only thing I'm going to highlight is that in my work, I'm very much fascinated by computational approach to understanding human behavior, which shaped the entire direction of my research and academic work so far. I've been really fascinated by the way we can understand individuals and population behavior by studying the patterns in the digital data that we generate through the use of smartphones, wearable technology, and social networks. And really, I wanted to, in this talk, to give you a bit of a flavor of a very unique times that we are living in right now that give us this enormous capability to understand the reality and humans through the digital technology that they are connected to. And the connectivity here, ladies and gentlemen, the fact that we live in a connected world, I perceive this global adoption of smartphones and associated digital devices and services as one of the most transformative processes in our reality. All of this is about the connectivity, about the fact that we reach the point in the technological development where we can really truly take advantage of powerful, fast, ubiquitous digital devices and the connectivity capability that they bring. And let's make no mistake here, we really are in the world where a lot of us are right now heavily connected individuals. There are 4.66 billion active internet users, which represents around 60% of the world population. Also, there are about 3.5 billion people with smartphones globally. That's about 45% of world population. Now, if we count in individuals who have mobile phones without the more advanced, more high-speed internet connectivity, this number goes up to 5.2 billion of mobile phone owners around the globe, which is almost 65% of the world population. And really, what this enables us to do is to almost create like a digital layer, which in turn makes the mechanics of our physical world more efficient. What I mean by that is that we live in times when our education, travel, shopping, work, entertainment, social communication, and content creation is massively empowered by the digital devices that we own and connect to. And we have also an unprecedented era of choices and options. Now, what this digital connectivity also brings is the ability to collect and use data. Data itself, of course, is just a tool, but this collective ability to produce and exchange it is really a game changer. And it's a cliche to say that everyone in the society benefits from the digital data. Governments can make better measurements of the success of their programs, hopefully. And media and other non-government organizations can use data to support their work and check facts. And the process, of course, is further facilitated by our connectivity enabled through a large number of social media platforms that we have available. You can see from this slide that, in fact, our world population right now is far outnumbered. Our virtual population, our digital population is far outnumbering the actual world Earth population. We can see from this slide that there are currently over 3.7 billion Facebook users, 2 billion YouTube users, and 2 billion WhatsApp users, and so on. The world with social media, we are in fact represented in multiple ways online. On average, each of us have around 8.5 social media accounts. And this, of course, creates a vibrant and active communities of interlocking interests that reflect and enrich our world. And all of these connections, of course, generate a massive amount of data. Now, the data revolution brings a lot of untold benefits to the citizens. We can have unprecedented insights into how people think, behave, and adhere to norms or deviate from them, both at home and in every society in the world, both in the individual level, but also on the population or country level. And here is where my sort of key interest has been focused on. I'm really much fascinated by this second layer in our existence, in our reality, the digital layer. And when we talk about this this enormous big digital data that's generated as a result of our connectivity, a particular case I wanted to highlight is related to a health innovation that are driven by digital technology. Of course, that's just one of the cases where things are really transforming rapidly and in a very much science fiction direction. But I thought that this would be a nice case here to illustrate some of the transformative processes that have occurred in the recent years as a result of this ubiquitous digital connectivity. So here I frequently refer to as digitally extended human. This comes from this notion developed by a Canadian philosopher of the 20th century, Marshall McLuhan, who talk about technology as being an extension of ourselves. Now, McLuhan was very literal about when he talked about technology being this extension of ourselves. He talked specifically about car being an extension of our ability to move and commute on a large distances, so almost an extension of our mobile system. He talked about camera being an extension of our eye as a way to capture and memorize the world, but also see and insight some aspects of the world that an eye can't actually capture. In our times, this thought of Marshall McLuhan, who was writing in 50s, is suddenly becoming really really powerful, really striking when we think, for example, about smartphones and wearables in particular. Those are indeed one of the most sophisticated examples here. When I talk about this technology being an extension of ourselves, what first comes to my mind is one of the experiments from Clayton and team that they done a couple of years ago, looking at this phenomena of a smartphone separation. So what they did, they invited a group of participants for an experiment, and they asked the group to take part in a simple set of cognitive tests, you know, IQ tests and so on. And they told participants, well, when we'll be doing those tests, we want to measure your heart rate. So we're going to attach this heart rate monitor to your chest. But unfortunately, this heart rate monitor is quite sensitive to your smartphone signal. So could you just take your smartphone and leave it there on the shelf on the side so it won't interfere with the signal of the recorder, of the heart rate recorder. So when participants then were taking part in this task, they were filling the tests, they weren't aware that actually that wasn't a real goal of this experiment. During this process, the researchers actually called the participants so they could see that their phones started vibrating there in the shelf when they were still participating in experiments, strapped with all this gear to measure their heart rate and some other biophysical characteristics. And what happened then? Well, their average heart rate actually increased by 10 beats per minute when they were prevented from answering their iPhones when it was just lying there on the shelf. And at the very end of the experiment, when they were finally reunited with their smartphones, their heart rate actually dropped by 13 beats per minute when they got their phones back. So I think that there is probably no better testament how much we are actually attached to our smartphones, that this small anecdotal experiment done by Clayton and colleagues in 2015. And the reason, of course, is that also since smartphones and wearables are very sophisticated technologies, packed with sensors, multifunctional, and connected, as I said earlier, with almost every aspect of our life. When we add to this sheer number of social networks and digital services that we are connected to with these particular platforms, it is really enormous amount of data that's getting generated, something that we refer to as digital traces, a tiny footprints of data that we as individuals leave in the daily usage of those different digital extensions that we have. Now, we know already that we can use those digital traces to profile and understand behavior of individual groups. But how specifically? Let's look at a couple of examples here. First, a very basic sensor, accelerometer, the one that's one of the most kind of traditionally occurring in smartphones and wearable technology that responds to the level of movement, was originally designed so that we could, when we invert our phone, the screen would react and got inverted as well, later expanded for gaming. But recently, it's been in the center of any self-tracking technology in terms of tracking performance and cycling activity. And in fact, it's been widely used to predict whether you are sitting, walking, jogging, cycling, or driving, or even what kind of public transport you are using, with up to 95% accuracy. So for just using the data that's recorded by these three-dimensional sensors that measure movement changes in your smartphone. The same sensor, for example, can be also used to evaluate your quality of the sleep from just the body movement. So it's sensitive enough that if it's left somewhere on the bed and the right applications are activated, they can actually detect a movement of your body that is changing during the different stages of sleep that you're going through. From other different metadata and data that smartwatch generates, simple things like call logs, text message logs, and Bluetooth scans and application usage profiles can be used to predict personality traits with up to 70% accuracy. Another type of this metadata, such as basic app usage logs and profiles, can tell if you are a parent with accuracy between 70 to 90%. And further, the length of your text messages or other messages that you write and how fast you type or erase it can be used to identify your mood or a global emotional state. In another way, stress levels can be also detected with up to 80% accuracy by capturing only a few words with a microphone. And even this is not about the meaning of the words, it's about the sound of your voice, about actual just the characteristics, the vocal characteristics of your voice, how fast you are talking, how loud, whether there are particular frequencies higher or lower present in your voice can really strongly indicate stress and other emotional levels. But of course, this effect or use or potential use of the digital traces in understanding individuals and profiling them doesn't only apply to just these raw sensors that our smartphones and wearables have. It also applies to, of course, data that we generate through social networks. As one of the examples, collection of your Facebook likes can reveal your age, gender, ethnicity, happiness, intelligence, use of drugs, personality traits, parental separation, as well as religious and political views, with up to 80–90% accuracy. And this is where we're only talking about your likes content, the type of content that you like, that can indicate all those, that can predict or indicate all those characteristics. Now, I mentioned earlier that in the particular area that has been recently affected and brings enormous potential for the application of those technologies is healthcare innovation. And let's also bring some examples that directly relate to this, that are quite striking from recent studies and experiments. In one study by Stanford Group, they show that heart rate, skin temperature, and blood oxygen level that were recorded with simple wearable device that can be purchased for a low cost on the consumer market could be used to identify early signs of Lyme disease, inflammatory responses, so some sort of infections, and physiological differences between insulin-sensitive and insulin-resistant individuals. So in this case, the researchers compared some of the signals that they got that I mentioned here from the wearables that the participants were wearing, and also from some clinical markers that they used. And they found that actually they could only need the wearable data to make an indication that something is happening. And this is quite a powerful point here, because it opens the door for what we can call as preventive predictive diagnostics, that will be able to capture that something is changing in our body and or some illness or infection is developing before we actually feel that this is happening. In a similar manner, wearable activity data in another study from group in Stanford show that wearable activity data can be used for cardiac imaging to determine how the size of the heart is influenced by the physical activity, and for this area called lipodomics to identify species of particular proteins that are associated with obesity, diabetes, or heart diseases. Again, in this case, the wearable activity data was compared to those cardiac imaging and tests that were done with the clinical grade devices, but they showed those really clear associations that were between those two sources of the data. So the predictive preventive diagnostics, this emerging promise that we will be able very soon, or we already have the potential to actually take this data and use it in a constructive way to make predictions about health conditions. And of course, another domain here is the potential for facilitating behavior change that's closely related to some sense to the diagnostic capabilities of the consumer devices. In here, let's think about the simple statistic that almost 50%, 45% of risks that are attributed to the higher mortality are risks such as high blood pressure, high cholesterol level, physical inactivity, or obesity. And when you look at those particular conditions, it's quite clear that a lot of them could be addressed with the right behavior change interventions. And wouldn't it be great if the same technology that allegedly put us in the couches, that really stimulated the sedentary lifestyle could be used to actually target such issues? Almost all of those, if they are used in the right way with the wearable technology, could be somehow addressed in this way. And the principle behind this, how this could be addressed, is coming from a quite old theories around the self-tracking and feedback. But because of this emergence of personal digital technology and the fact that the smartphone is with us continuously during the day and by our bedside during the night, and is one of the first things we grab in the morning, and the fact that there are personal devices on our wrists and other parts of the body that also take those measurements, those theories suddenly became more real, more instant in terms of the feedback that they can provide, more personalized, and also the fact that this process can be continuous, intelligent, much more detailed than some of the solutions that's been used in the past, such as self-report surveys or questionnaires that, of course, require you to introspect, understand the question and make some answer. While in here, there is just a stream of data that's getting evaluated by the algorithm, and it infers whether there is a point where it could suggest something to you. There might be some change, or that you maybe should consider going to see a GP because your heart rate is showing some abnormal patterns, or that your levels of activity dropped below the levels that you would like to have. But now, unfortunately, while all of those things seem quite powerful and bring a promise of true revolution in healthcare, we didn't quite see this yet materialize in the real world. And that's, of course, because our interaction with technology is also quite complex, psychological or cyber psychological subject. The relationship is not straightforward. As one of my colleagues said recently, you can't give a person, an obese person, a weight scale and expect that they will lose weight. In the same sense, you can't just give a person a smartphone or a wearable on install an app and expect that immediately this information will have an impact, or this will have an immediate impact on the change of the behavior. There is something more in this, and we've been looking at this problem for a while now, and we realize increasingly more that, of course, individual differences play a large role. Our norms, beliefs, attitudes, motivation, personality traits, cultural influences, socioeconomic factors, broader context of how we live and how we use technology actually have enormous impact of how we apply them in our health behavior. We wrote about this a few times, and we also acknowledged quite recently in a paper we published in the Journal of Royal Society of Medicine that recent studies are still quite failing to materialize this huge impact of encouraging physical activity and fighting sedentary lifestyle with the use of wearable technology. And what have we found in this? What sort of problems we identified? What obstacles we have specified in this process? Well, I guess that there were two groups of those. I'm going to just briefly discuss them here. One group is related to human-computer interaction issues, and another to what we can call theoretical rigor. The HCR, human-computer interaction, is mainly driven by the fact that very frequently those devices can be intrusive to the participants or disliked. The constant untimely notifications, the reminders, we still get them through other platforms. If we add the layers of those notifications coming from tracking apps, that can become overwhelming, and participants frequently turn it off. And that's also reflected in the statistics that show that attrition rates are very high for wearable technology and apps that are used for self-tracking, like fitness apps. Participants have initial hype with those tags, but quite quickly drop them because the hype dries off. They might perceive them as being solution in search for the problem, where they don't really perceive the added value for the longer period of time. We have, of course, identified a couple of potential directions how those issues could be mitigated. Device design, for example, we suggest could be driven by researchers and end users, as well as those working within health. So we need the interdisciplinary approach in implementation of these technologies in healthcare to understand those viewpoints coming from different stakeholders. Also, understanding the role of individual differences, what I mentioned a minute ago, to predict uptake, success, attrition of future interventions. And finally, quantifying behavior interactions from wearable technology. So, you know, one of the power of those devices is that we can actually record a lot of information related to just a context of the activity when the individuals are using this type of technology for tracking. So we don't need to really make a survey. We just have to understand and extract the right data that can quantify and give us better understanding of how people actually are interacting with those devices. The second class of problems that we sort of identified as obstacles in adoption of broader adoption of wearable technology and apps in healthcare are more related to some of the theoretical obstacles, that frequently a lot of interventions are theoretically uninformed, and there is really quite unknown mechanism of action that occurs between us and interaction with these complex technologies. So again, as a set of suggestions, we suggest that probably it's a good idea to start testing different behavior change interventions with the digital interventions in order to understand how the two interact in the context of some more traditional approaches. We never claim that this type of tech will on its own solve all the problems. We see it more as supplement to the existing interventions, as a way to boost it, as a way to provide individuals with more informed, more direct platforms, also to get an access and insight into their own behavior. But of course, we have to first understand how those could interact with existing intervention. But also, of course, we have to start unpacking some of those causal pathways, which refers to some of the previous points, that when we start looking a bit more closer at the interaction with those devices, at some of the data that's in there, then it will help us to unpick some of the causal relationships in how we are using this type of tech. So there are, at this stage, I guess, it's still a growing area. The manufacturers of wearable devices are, of course, all jumping on the wagon, and some of them are already making a conscious and clear approach in the direction that they recognize there is something more to be done in implementing those technologies in a healthcare setting beyond just counting people's steps. That this is not sufficient, that the platforms have to be more personalized, more expanded, more carefully trimmed and aligned with behavior, and the algorithms have to, and data has to be slightly more sophisticated in terms of how it evaluates individuals' behavior. But there are, of course, some positive points that have been almost accidentally happening as well in this digital domain, and I refer to one of those anecdotally, also quite funny one in a sense, and that refers to Pokemon Go. You might remember it's been very large phenomena in 2016 when it had almost half billion downloads, and it still has about 20-30 million active users, over 3.6 billion in lifetime revenue that manufacturers or the developers of this solution created. You might remember that the idea with the Pokemon Go, with this smartphone game, was that you were going around the real world, the actual physical world, with your smartphone in front of you, and you were basically just hunting and throwing those Pokeballs into small virtual monsters that were overlaid on the actual real world. So it was based on the geolocation algorithms that were spreading those small beasts all around the cities, and gamers were just running around the cities and trying to catch those Pokemons. But what Microsoft researchers actually noticed in this period, that there was overall a 25% average increase in the physical activity for users who played Pokemon Go across genders, ages, weight statuses, and prior research activity levels. So those factors weren't actually influencing this. So this is really kind of a nice example of almost an accidental effect of digital technology on physical activity that through gamification elevated a large number of people to actually move more, be more physically active, and of course, as a result, contributing to their health. Before I move to my next part, I'm just going to quickly check if I have any questions there in the background. Okay, so I have some questions, so I'm going to make a quick pause from the slides for a moment and just address some of those questions here. Roya, sounds we human beings are having less and less privacies, like our personal traits are being found out by image and social network and so on. That, of course, is a very good point, Ruyu. Absolutely. One of the clear consequences of what is happening right now is that we are gradually losing our privacy, as they are on average 8.5 different versions of us online. And a lot of those social networking services that we're signing to, a part of them is sharing the data. That is, of course, bringing a lot of challenges to our privacy and and I guess that this brings a sense that we are losing control over this information and privacy. And this is something that's going to be a very big topic for discussion. It is already right now, especially after some of the recent events such as Cambridge Analytica crisis or what's been happening around disinformation campaigns on social media, and how also individuals were allegedly profiled and targeted with particular advertising, political advertising. All those issues bring a lot of challenges for privacy, and I think that there will be a lot of discussion around this, and the discussion will have to involve stakeholders from the government side, from the technological companies side, from the consumer side, and from the businesses side. This is because the problem is really complex if you think about it. The platforms, of course, are trying to make sure that they follow particular rules and that they are responsible to some extent, but of course they also want to make a profit. They are companies that are embedded in the capitalistic world, and most of those companies, especially social media companies, are making money based on ads that they're posting on their platforms. So of course the governments then have to do their work to try to make sure that those companies don't step out of the line or don't create the practices that are violating our privacy or that protect us correctly, but also that don't stiffen the innovation and progress in this sense. But of course, there is always the consumer perspective, and it's a very complex problem. And I guess in Europe, for example, GDPR has been one of the recent strong attempts in trying to address this issue. But it's very much a huge topic that would probably create a completely separate session for us, where we could broadly discuss it. So I'm just going to go to the next question from the anonymous participants. And what about data privacy and security? I have seen so many cases of personal data being compromised or exposed without the user awareness and explicit consent. So again, I feel that I already started slightly to answer this question. I will come back to it in some of my later slides. So we're gonna touch on this a bit more. How you're seeing nanotechnology into the medical sector? Okay, I guess that nanotechnology is slightly beyond my area of expertise, to be honest. I'm not a nanotechnology engineer. I only know about this from more kind of on an anecdotal, broad perspective. But of course, I'm super excited as a keen reader of science fiction literature. I see this as a next step in our technological evolution, the fact that we'll be able to actually implant this wearable device into our body, inside our body, and then this will be able to provide us with a complex, almost real-time blood screening on a particular indicators, so that we are definitely going into this direction, that we are making devices smaller and closer to our bodies, because we immediately recognize the value that it will potentially brings into the medical sector. Another question from Rajeswari, aside from clinical analytics, how can business analytics help in the medical and pharma sector, as the pandemic has shown us the need for predictive analytics in a more immediate sense? Yeah, very good question. I guess that it's in some sense it's already present there, of course. You know, in the current research even on the vaccination, where they squeezed the 10-year process into 10 months, there were a lot of employment of predictive analytics in this process to try to speed up some of the clinical studies and developments and analysis of samples. So of course, but again, I'll come back to this point in a part that I'm just going to get to, because it touches on some of the machine learning aspects I'll be talking in a minute. Our wearable technology, the next stage of human revolution, they are the part of this digital revolution, absolutely. But maybe they also signalize that the direction will be able to become kind of, as I said point earlier, smaller and more into the bodies. You know, that this is really kind of where it's potentially going. Then another anonymous question about the privacy issue. So again, I'm going to skip it for a moment, come back maybe a bit later to this. Okay, so I might come back to some of those questions just after my second part that I'm going to move to just now with machine learning that I promised to cover today. And you know, as we talk about, of course, predictive models, we talk about this aspect that how predictive analytics, behavior analytics is getting enabled also, is getting used to such an extent with the digital sensors. There is, of course, a question about the role of machine learning in this process. But what the heck is machine learning? And, you know, I thought that I would just give you a very quick crash course, a tiny primer to just clarify maybe some misunderstanding around the machine learning. Because to really start with, machine learning is not a new thing. You can trace, you know, the origins of those concepts to early 50s, when the kind of AI and artificial intelligence machine learning movement started to gradually emerge. In general, machine learning is tightly related with artificial intelligence. Machine learning is the science of getting computers to act without being explicitly programmed, while artificial intelligence is a broader concept that encompasses it as a branch of computer science that attempts to build machines capable of intelligent behavior. So in short, you need AI researcher to build a smart machine, but you need machine learning experts to make them truly intelligent, okay? And in this model also, we've heard a lot about deep learning. Deep learning is a sub-discipline or subset within machine learning, and I'll also briefly refer to it in a second. So let's leave it there for a moment. It's basically one of the development within the machine learning domain related to the neural networks that happened, that's really also exploded in the recent years because of some of the technological drivers and changes. So as I said, we can trace the origins of the concepts around the AI machine learning to early 50s, when the handful of pioneers in computer sciences started asking a question whether computers could automate intellectual tasks that are normally performed by humans. One of those pioneers, quite noticeable one, was Alan Turing, who published his seminal, very influential paper titled Computing Machinery and Intelligence in the journal Mind in 1950. And Turing really started to juggle with the question whether computer could learn on its own how to perform specific tasks. Could computers surprise us rather than programmers crafting data processing rules by hand? Could computer automatically learn those rules? And those questions were really, really important because they opened door for completely new programming paradigm. Let me clarify this a bit more in detail. In classical programming, humans input rules, that is the program, sometimes called a program, and also the data that should be processed according to these rules. And out comes the answer. Now, machine learning really shifted this paradigm. Humans also input the data, but also the answers expected from the data. And out comes the rules. Now we can take these rules and apply them to the new data to produce original answers. And in this process, in a sense, machine learning system is trained rather than explicitly programmed. It is presented with many examples relevant to the tasks, and it finds statistical structure in these examples that eventually allows the system to come up with the rules for automating the task. Machine learning is, of course, tightly related to mathematical statistics, but it differs in several important ways. First, it deals with the large and complex data sets, for which classical statistics such as Bayesian analysis would be just impractical. But as a result of this, it also exhibits comparatively little mathematical theory. And I'm sure some of my colleagues from IDO division here in the University of Bath would say it probably exhibits too little mathematical theory, that it's too engineering oriented. But for those of us who are more on the practitioner side, this is actually very good news. It's because it's very much hands-on discipline in which ideas are often proved empirically more than theoretically. And of course, the reason it's exploded in the last 15, 20 years is, again, because of those drivers that we already mentioned, the improvement in computer speed and in memory storage, easier access to the fast internet and cloud computing, low-cost, high-resolution digital sensor, the big data and the computational power really enabled us to take those concepts that were developed in 50s, 60s, and then we had some of the AI winters because we didn't have power to do anything with this, but now we have it. And in the last 20 years, it's just been incredible. And that sort of leads me to sort of another actually sort of point on how do machines actually learn. I thought that I'll again give you a bit of an understanding of this aspect, just very briefly. So in a sense, we call it learning because this is about learning representation from data. And of course, from studying human development and human behavior, we know that every intelligence has to be taught. Human brain, which is genetically primed to categorize objects around the world in the reality, still needs to see a dozen examples as a child before it can distinguish between cats and dogs. Now, if you want machines to do the same, well, we require three components for this process. There are three components that you need to teach machines. The first component is input data points. For example, if the task is image recognition of cats and dogs, you probably need a lot of pictures of cats and dogs that you want to use as your input data. Then, as a second component, you need examples of the expected output. So for example, if the expected output in this image recognition task would be a tag that would name one photo as a dog and another photo as a photo of a cat. And finally, a third component, we need a way to measure whether this algorithm is doing a good job. This is necessary in order to determine the distance between the algorithm output and its expected outcome. And this measurement is used as a feedback signal to adjust the way the algorithm works. This adjustment step is actually called learning. So a machine learning model transforms input data into meaningful outputs, a process that is learned from the exposure to known examples of inputs and outputs. In short, machine learning models are about finding appropriate representations for their input data. So transforming particular data that makes it more amenable to the task in hand, such as, for example, classification task of pictures as dogs and cats. This term, the representation, this is the core in a different way to look at the data, to represent or to encode the data. Now, if I want to kind of capture or summarize this in one sentence, I would say that overall machine learning is a process of searching for useful representation of some input data with a predefined space of possibilities using guidance from the feedback signal. And that's how we teach machine all these things, such as identifying filter spam messages from email, automating traffic signals according to road condition, approving or rejecting loan application, providing cancer diagnosis to support clinicians, recognizing speech in various languages, contextual search engines, auto-piloting planes and auto-driving cars. All of this are examples of almost like a classic recent application of machine learning where we see this distributed around our reality. Now, but what about deep learning? Okay, we hear a lot about this process. We hear a lot about deep learning in media recently, Google DeepMind, and of course the Hollywood culture, which brings really, of course, another dark scenario of what deep learning would bring, that this is the beginning of the Skynet. And we, ladies and gentlemen, are not quite there yet. Deep learning is a specific subfield for machine learning that takes a slightly different take on the learning approach and puts an emphasis on learning successive layers of increasingly meaningful representations. So the depth in deep learning isn't really a reference to any kind of deeper understanding achieved by the approach, but rather it stands for this idea of those successive layers of representation, and how many of those layers are basically contributes to the model is called that its depth. I had a brief overview of the history of how it emerged here, but I'm just going to quickly try to skim through it. But overall, the deep learning, again, the basics of it were created in the 50s when computer scientists and mathematicians were juggling with the digital neural networks, which were the type of computationally created artificial networks having a similar characteristics to a functionality of a human neuron in the brain. But of course, it took decades to attain the astronomically huge combinational relationships between the hundreds of millions of neurons that we have. And because it requires many simultaneous processes, it wasn't really possible to apply a proper neural networks until 21st century, and specifically kind of around 2005. There was a particular development in computer games, and this is I wanted to mention because it's quite kind of almost ironical that actually development of and drives around computer games were one of the things that empowered this new revolution in deep learning and the use of neural networks. And that's specifically the development of graphical processing unit in early video game consoles, where there was a need to calculate millions of pixels per second. By 2005, they were so broadly distributed, and it was so cheap that practically became a commodity. And now, around this time, also researchers in Stanford University, Andrew and G, realized that those graphic processing units could run networks in parallel. And this truly unlocked new possibilities, because traditional processors require several weeks to calculate all cascading possibilities in those neural networks with 100 million parameters. And he could achieve this with a cluster of those graphical processing units within a day. So that was the first transformation that then really enabled kind of deep learning to be taken to the next level. There was just a small tweak that another researchers made around the same time, which he dubbed specifically deep learning, to mathematically optimize the results from each of the layer of neural network, so that the learning accumulated faster as it processed through the stacks of layers. Mind you, in a traditional learning, machine learning, which we sometimes call shallow learning, you only have 1 or 2 layers of representation, maybe 5. In the deep learning models, you can have hundreds of those layers. And this is now, of course, the essential component of all current AI systems, IBM Watson, Google DeepMind, Google search engine, Facebook face recognition algorithm. This one is insane. It can search through 3 billion faces and recognize you from this within seconds. And this is all, of course, driven by those methods. So the deep learning took all of those things a level up. It really kind of leveled up the way machine learning is right now used in a practical application. It gives us a near human level image classification, speech recognition, handwriting transcription, improved machine translation, improved text-to-speech conversation, all the digital assistants that we are surrounded by, near human level autonomous driving, improve task targeting, of course, ability to answer natural language questions, and of course, superhuman Go playing abilities, as the Google has been showing, as well as Space Invader playing abilities. That's also computers are better in this. But, well, of course, there are problems. As always, there are some problems with it. It's not such a dreamy, perfect world, and some of those problems were already highlighted by your questions, ladies and gentlemen, that I looked at. And just to give you a couple highlights of where those problems are coming from and how they are related, of course, to aspects mainly pointed down to well, some of the ethical privacy issues, as well as just a big problem with the biases that those algorithms can have embedded within their functioning. So one recent example is when Admiral used algorithms to identify risky drivers based on Facebook posts in order to price car insurance. What they did, basically, they started scraping public repositories of social networks for photos of individuals who signed up in their insurance program. And they use machine learning to indicate risk inferred from those photos. So if you had a bit of a drunken party photo, or with a particular you might be classified as a more risky driver. Of course, this program was slashed and they had a massive backlash at that time, but it shows, of course, that there is already this potential for that kind of practices. Another one, researchers at Cornell University a few years ago found that if you set a user gender to female in the Google search, this resulted in females being served fewer ads for high-paying jobs. So basically, what you have is a clear gender bias that has been embedded right away into the search algorithm. Google fixed it since then, but again, it shows us how serious those problems can potentially be and can impact our lives. Another, more on the joyful side, the American supermarket chain Target sent coupons for baby items before customer knew that she was pregnant. What Target did, they were using this quite sophisticated and also some simple association rules algorithm, machine learning algorithm, to determine what coupons are best to send to the customer. And this particular customer apparently had a pattern of purchases that was suggesting that she's pregnant, so they sent her coupons for baby items, and she found out that she's pregnant. So again, we have this predictive phenomena that's happened even before she realized that and had any medical examination on a pregnancy test. And finally, of course, a kind of a more broader application of this on the governmental or nationwide scale, the social credit system that has been developed experimentally in some regions in China, where the state starts monitoring many aspects of an individual life, such as employment, hobbies, also particular patterns of purchase, to give a score of individuals based on trustworthiness. So again, this is almost like a Black Mirror, Charlie Brooker scenario. If you know what I'm talking about. If you don't, please watch this BBC show. Although I have to stress it's quite dark and heavy, but it's really this sort of dark, slightly dark dystopian sci-fi scenario that we will have this score, quantitative score assigned to us, evaluated based on particular social activities that we have and other activities. And that score defines potential access to the services and products, as well as other privileges. So that is, of course, quite some of the worrying developments. All of this, in part, stems from this what's called in machine learning a black box phenomenon. In particularly with those more advanced deep learning techniques, it's very difficult to know how particular decisions are reached. Deep learning techniques provide prediction, but they don't necessarily provide insights into how the variables has been used to reach those predictions. So it's like a black box that we can't quite decode, and the mathematical complexity is too much to unpick in those more complex applications. This is, of course, particularly important for trying to prevent discrimination in the trained model, like the one I mentioned about the gender discrimination. So, in a sense, this kind of the final part of my title was the future of the analytics. And I kind of slightly, potentially I was a bit cheeky here, because I just wanted to say that the future is actually already here. It's just not evenly distributed yet, by paraphrasing or quoting one of my favorite science fiction authors, William Gibson, who said it. And really, I couldn't agree more. Ladies and gentlemen, we live in a very unique times when technologically we have enormous capabilities, enormous amount of choices, and there are so many potential directions in how we can use this to make our and other lives better, to improve the functioning of organizations, governments. Almost every aspect of our life could be addressed and improved with the right application and elevating this data. So we are already living in this future, in a sense, because all those those science fiction scenarios from 70s and 80s are now fulfilled in a way, and we can clearly see in which directions we are heading with some of those phenomena. But of course, there is still a lot to be done, a lot of research, a lot of practice, a lot of implementations. I gave a couple of examples here of those large companies like Amazon or Netflix, who is basically making shows that are based on the data that's getting evaluated by those deep learning algorithms, and recommends what sort of combination of factor would make the best production that will be successful. So those are the companies, and Amazon, that places whole business model on kind of data-driven approach. Those are really kind of quite special and unique examples. But in a broader scope, there are still a lot of small and medium industries that don't really take the full advantage of it. Only a tiny percentage of the data that we generate is actually ever analyzed and used. And this brings this enormous potential for all of us, ladies and gentlemen, in our development of skills and capabilities. And I guess with this thought, I'll leave you with this thought. Thank you very much for attending and tuning into this session. I will now jump to questions to start addressing any of those that we have. Carol, asking question again, could our smartphones work as ECG, EKG, CPR? So Carol is referring to some of the medical device, electrocardiogram, and so on. So some kind of medical imaging devices at the same time. I don't see reason why not. In fact, there are already case studies when, especially now with the pandemic, when GPs and health practitioners used as simple features of a smartphones, like a good quality cameras, to make some decisions in diagnostics. So I don't see a reason why those more sophisticated imaging tools will be ported to the smartphone and wearable technology and will be a part of our risk. In fact, Apple Watch is a good example. Apple Watch has right now medical grade electrocardiogram. That's a part of its platform, a consumer grade watch that has basically a device that can cost thousands of pounds to purchase for the hospital, that you can have on your wrist and have a continuous and on-demand screening of these particular parameters. How you are seeing inserting a chip in the human mind for an advancement of human into medical? And I think work is going on into it. Yes, indeed. So that's anonymous participant, but with the initial W. I won't be the early adopter for the insertion of a chip into my brain, but I might be a second in line for this. I would be happily do it as a kind of when I see the first side effects, and if it's gonna work, I'm gonna go for the second adoption. But the brain, of course, it's a very complex problem because we, as a scientist, we still don't understand a lot of principles of how the brain works in terms of the neural activity. There are some really promising localized approaches, for example, for patients who are suffering from a locked-in syndrome or a severe paralysis from the neck down, or unable to communicate. There are already clinical studies that show implementation of wireless chips in particular parts of the cortex, motor cortex, then maps the signal from the cortex into the computer screen so they can use a cursor and basically some digital extension to make choices on the screen. And this is already super powerful if you think about it in this phenomenon, this scale. Well, there will be a possibility of those individuals basically getting immersed almost in the digital world that will be only steered with the power of a thought, which is a complete science fiction concept, but we are getting closer and closer to it. The sociodemographic would be essential to allow another question for automated feeds for proactive design of public services, shorten life cycle, so quicker respond to current issues rather than always behind the curve. Couldn't agree more to this comment. Absolutely, that's of course the problem also from the business perspective in this particular point, because businesses are very sensitive about their data and their proprietary algorithms that they develop to read it. So, for example, for us as a scientist, it's very frequently very difficult to use those devices for any research or for any evaluation, because we're just constrained within the limited platform that they might create. But it's getting better and better. So I think that we eventually tackle this. Another question: what tactics and personal skills do I need to have to cut down the amount of time my students spend in smartphones more than the chance they listen to me during class? I'm talking about middle school students aged 13 and 17 years old. Oh, Carol, it's a very tricky question. I think that it's a lost fight. It's a lost fight. We just have to streamline with time and just implement the educational technologies as much as we can into those platforms that they are using to communicate, so that it's also an extension to the educational aspect that they have, or the educational platforms as a part of it, which I think that primary and secondary education is strongly moving into, as much as higher education as well. I mean, I haven't mentioned much about this point, but in our programs, we of course are taking advantage of the newest cutting edge solutions in analytics. But in this sense, I don't think that we can win this fight easily with the adolescent generation. Knowing what you know about the data that this technology collects and how it can be used, I'm interested to know if you use them yourself. Well, yeah, of course. I guess, Rainer, the question is about whether I'm using it for my research or if I'm using it personally for. Well, I guess that the way I use it is to empower some of the research we are doing. That there were a small kind of indicators of this in this masterclass around the wearable tech work that we're doing. But we also do a lot of work right now with social media and Twitter in understanding patterns of polarization, disinformation, using methods of text mining in sort of analyzing the past Twitter feeds and behavior of individuals. We are very much trying to look at the responsible practices and methodologies as well with those devices. So thinking about, for example, one of the projects in how we can better design research apps so that we respect users' privacy, we address the security issues instead of using some of the platforms that we have doubts about in terms of the data security. Your question also might be whether I'm actually using this technology, and in this case the answer is very heavily. I embed myself in the digital world 100%. I have about 3 different assistants spread all over the house that steer, that I can control the light. So the automation, Internet of Things aspects, I'm very early adopter with those things. With wearables, I probably tested about 30 different types in the last 8 years. Kind of very curious about how they work and what's the principles. I even kind of dissected them and started to playing with the guts of those to sort of better understand what's happening there. And you can do it with platforms like Arduino for prototyping. So yeah, I'm deeply there. I'm very much a technological generation. What about socioeconomic bias of the data? Well, yeah, another anonymous question. Very good point. I guess that what you mean is the fact that, of course, parts of the world don't have this digital connectivity and pervasiveness of how those technologies are surrounding us as we have in sort of in the Western developed world or in some kind of more developed regions of the world and countries. Still, saying this, if you think about this, all the 5.2 billion people who own a mobile phone globally, 65% of the population, a lot of those populations are in the underprivileged sociodemographic backgrounds or regions of the world. In fact, the price barrier and the accessibility barrier is getting very much lowered with the digital technology. I mean, just from my subjective experience, and also I'm sure many of you also have this experience. I've been traveling in some region in Asia 2 years ago, in Laos specifically, and in the north, in the jungle, I encountered these villages where there wasn't really access to proper sanitation system or some of the basic technologies that we would take for granted. However, a lot of individuals who were in this village had a functioning good level smartphone, which are now affordable for potentially something like $20, $25. So the accessibility barrier is definitely going down, and in this sense also, because that makes us a bit more equal, because in the internet, in a sense, it's a socialistic platform. You know, we all have access to the same services, unless of course you have some government limitations on the access to the services. But otherwise, the accessibility is increasing. But the bias, well, the bias is something that we have to try to address as a responsible researchers and responsible practitioners in every domain. And it will be a difficult one to address for things like gender bias, because sometimes this is even embedded with the data that people are working with. And the thing is to then supplement it with a different data so that the algorithm or model that you trained will not have this particular bias embedded there. Although privacy remains a concern, another question, how we stand for time? I'm just going to quickly ask because I went into this hectic rant.
No, it's absolutely fantastic. It's so interesting. What we're going to do is just hand over to the course promotion, and then we can come back to the Q&A and get through as many more questions as we possibly can with you, Lukasz. Thank you so much. We'll be right back.
Thank you.
Thank you so much, Lukasz. That was really interesting and fascinating. It's an area obviously which will impact every part of our lives. So I do look forward to hearing from you in the future and getting updates and following your research on that. So thank you so much. Hello everyone, my name is Dee Marhill. I'm the Head of MSc Operations and Admissions for the MSc portfolio. And I'm delighted today just to give you a quick overview of Bath and also the MSc courses that we have to offer to you. As you can see in front of you, there's a beautiful picture, and this is actually of the city of Bath. This is exactly what it looks like when the sun is shining. It's very lush, it's very green, and it's very, very beautiful. We're very lucky to live, work and study in Bath. It's a very nice surroundings. As you can see from the slide there, it's a UNESCO World Heritage City. It lends itself to the Roman heritage, and as such, it's a very cultural city. It's a very vibrant city. And one of the great things about Bath is it offers all the benefits of city living, but with a very friendly, welcoming and community atmosphere. And it's been voted a very safe city as well, which obviously is just a lovely place to be in general. It's very accessible. You can access it by foot, by car, and if you're energetic and like the outdoors, like a lot of the people in the area, you can access it by bike as well. You can notice there that there's a QR code. If you do scan that code, it will take you through to living in Bath as a student, and it's got lots of more information about obviously what you can expect if you were living and studying in Bath for a year. For those of you who are new to Bath, just to let you know that obviously Bath is in the southwest of England, and it's probably about sort of 90 minutes away on train from London. So it's very accessible to get into London, get over to Manchester, Birmingham, and literally across the UK itself. We're very lucky that we live in close proximity to an international airport in Bristol, and obviously a lot of you might be aware of Heathrow Airport, which obviously services the UK in general as well. So now if we go on to look at the master's programmes themselves, the good thing about our portfolio is that you have choice. You have a choice depending on your background and obviously the various degrees and experience that you bring to us as well. It's not exclusive that you come from a business management background. Actually, a lot of our programs do ask for people to be from various disciplines, and that obviously adds to the variety and the interest of the people that you will actually meet on the course as well. You can apply for more than one program, which is great because there's obviously areas of interest there that might catch your eye, but also there's more of a generalist program. So for example, if we look at the MSc in management, it's designed as a general program. And the really good thing about it is it offers lots of optional units, and this really allows you to tailor your learning to your area of interest or to your career direction if you're already aware of what you want to go into. You might be very much finance orientated and you sort of want to build on the quantitative skills that you have got. That would be another area of interest, and obviously there are quite a few MSCs within that portfolio in the suite as well. Or you may prefer to choose a specialist degree. Obviously, Lukasz teaches on some of our programs here, and obviously from a business analytics point of view, you can see that there's a large area of interest. So that's one of our specialist programs. And what that will do is actually will develop your knowledge, not only of core business and management, but also of the specialist area that you're interested in as well. So please do take a look at those. I'd like to share with you now in our next slide is some of the shared features that we have on our MSc program. And these are actually embedded into all of our courses. So like I said, it's a 1-year full-time program. The next entry year will be now in October 2021, and applications are now open if you're interested in doing a master's for next year. Lukasz is a very good example of the quality of teaching that we have. He's very engaging, he's very interactive, and as you can see, he's very research-led in his teaching as well. So a very lovely example of the quality of teaching that we have here. And what that lends itself to is a very interactive and a very conclusive conversation in the classroom. You are getting taught by the individuals who are very passionate about their area of interest, and it's very relevant and very topical at the moment. So it does lend itself to a very good student experience in the classroom and beyond as well. You can see there that we've mentioned international experience. Obviously, with the pandemic the way it is at the moment, this is still very relevant to our MSc courses. And what we would do here is that we attract a large student body internationally as well as UK and in Europe. And we also attract staff from across the globe as well. And what that lends itself is to a very enriched experience within the MSc course and within Bath and the university and the city actually itself as well. Where we can and where we will is we will offer you international experience or experience in an international context to make sure that you have that wider overview to take you into the future and obviously enhance your experience. At the moment, well-being and support, and it's something that is a key thread in all of our MSCs and across the university, is very, very important to us, particularly given the current situation. You'll be supported not only academically by our academics and obviously a wider team, you'll be supported on your welfare as well. It's very important to us that you have a good student experience when you're with us. And we do realise that that can come with some obstacles and bumps, just as life does in general. We're very lucky in the school that we have a dedicated student experience team, which is exclusive to our MSc office. And we also do have an MSc team and a wider personal tutoring system. Again, all of these individuals are there to get you through a smooth process from the day you start all the way to your graduation, and we'll be part of that journey. And it's a very nice journey to be part of. So you are supportive, and this is support not only within the school itself, but it's also there are wider support mechanisms available from the university. So it's very much a caring environment and supportive environment, and very approachable as well. You'll see there that we've highlighted our career support. This is a very much an embedded key offering that we do offer to all of our students. Essentially, we're trying to get you business ready. We want you to be employable, and we want you to go on to do great things in the future. So very early on in your experience with the MSc program, you will actually have contact with our dedicated MSc office, our careers team, and they will look after you and really get to know you, have a one-to-one with you, invite you to a lot of topical employability conversations, allow you to meet with corporate partners and guests, and really start building up your network and building up your confidence to apply for those jobs and go on to great careers in the future as well. Lastly there you'll see is practical business experience. This is a massive undertaking from the School of Management and something that they do very, very well. And this is the point of getting you business ready. We want you to build not only your soft skills, your academic skills, but also your practical knowledge. This particular area allows you to apply what you have learnt in the classroom and actually apply it to the physical and business world, which is what employers will be looking for and what they obviously want to see from a master's level student as well. So we will give you plenty of opportunity to get involved in challenges, case studies, meet with guest speakers, meet with our corporate partners. You know, we'll open our book as much as we can to allow you to facilitate having that business experience. So hopefully that gives you a little bit of an insight to what the MSc portfolio has to offer. We're more than happy to take questions from you later on, or you're welcome to get into touch with the admissions team or any one of our careers team, and we'll be delighted to speak to you. I'm now going to hand over to my colleague on the MBA, and Steve Wyatt. Thank you.
Thank you all for tuning in. So we've talked about, or Dee talked about, the MSc suite of programs, and if you're mid-career, then you might be looking at an MBA. And so we have two very strong MBAs with some common themes and some distinct differences. The one is on the top is the full-time one, which is approximately 12 months long, although including opportunities for work placement, internship at the end, it can be considered as 15 months, depending on how you take it. And then we have a part-time MBA, which is run over a 2-year cycle. And in the part-time one, it's for folks particularly who are still in work and who can only spare maybe 3 days a month away from the office. We work, one of those 3 days each month is on a Saturday, so it's really only 2 days away from the office, and therefore the cycle is a little bit longer. There are a couple of similarities which I think are really important about our MBA design, and the first is that we attaching the academic content part to actual practical application. So in the part-time one, it's very easy to understand how that happens, because what you do is you come and learn in the modules, and then you're expected to apply that knowledge in the workplace. And so it's a very quick backwards and forwards from learning to application, learning to doing. In the full-time MBA, what we have is a suite of different projects that run throughout the year at key moments, typically at the end of a semester, where you apply into a consulting environment or entrepreneurship environment, or a capstone project environment. You're applying what you've learned most recently across different modules into a corporate setting or a startup setting. And so we believe very much that it's the application is very important. So that's a common theme across both modules, which is very key for us. Another part that's really important across both modules is, or both courses, is that we invest heavily in personal and professional development as well. So it's not only the practical application, it's the personal development and the professional development. And what do we mean by that? Is topics like interviewing skills, executive presence, mapping out your career journey, reflecting on the career you've had so far, particularly giving support to those of you who join and looking for a changing career rather than just simply an acceleration within the same sector that you're in. So the full-time MBA, giving you a quick overview there as to what it is, but there's opportunities as well to customize your own interest set. We have a set of core modules which you take, but 1/3 of the course credits actually come from your choices, your individual choices, the electives. So that means that we can accommodate the diversity of experience sets that you bring, or the cohort brings in total together. So people particularly like to focus with us often in more entrepreneurial aspects of business, or in ethics and sustainability and those kind of issues. But we have a whole array of electives, including finance and different aspects of accounting as well. I think the key part that's important is this opportunity to include the internship at the end, and that's a very important aspect for a number of our overseas students. The course size for the full-time MBA is about 50 people. We find that's pretty much ideal for us, because what we really want to encourage is interactivity, not only between the cohort members, students with the faculty, but also between themselves. And we find that's about the perfect size for us. So we are not going to be organizing cohorts of 100 and 150 plus. We keep it small, we keep it intimate, because we believe very much that interactivity is essential. And moving on to the part-time MBA, which goes on for, as I said, 2 years. In that, it's a standard program that you go through together with everybody on the cohort. There isn't the optionality, but there is this very strong focus on interactivity and working on problems. So although you're applying the knowledge learned in the program in your workplace, we also expect you to be working collaboratively with your peers, such that you can compare insights and experiences and you can learn from one another. And that's very important. A big focus in this course is very much looking at disruptive technologies and innovation, and equipping people to have an impact in their own companies, their workplace, and move those businesses significantly forward. I myself, my area is I'm the professor of strategy and leadership, particularly with relevance for the fourth industrial revolution. And I teach in both programs, and I also have the honor of looking after both these programs, and to really make sure that we live up to this promise of being both professional, practical, and personal orientated, and looking at the most relevant issues of the current businesses are currently facing. Again, if you've got any questions, please don't hesitate to reach out to me directly or place them in the chat later on. Thank you.
I will try to answer as many as I can, but we might have to finish at some point. There are quite a lot of really good questions, so thank you for a fantastic question. From Anonymous, although privacy issues remain a concern, the fact that you care enough to achieve homeostasis, you could reduce the privacy risk with selective consent, just as cookie to web visit, or get option to delete, get regular reports on what data is taken to date. Absolutely, very good point. I also believe that this issue of privacy management across those multiple identities that we create online will become quite central in the next couple of years. And I even have a suspicion that governments will get involved and they will try to lead some verification and validation regulation process that will actually give us this kind of tick for everyone that has the repository of the social profiles, and this will somehow be managed. But again, how it's going to be done from a technical perspective, it's very difficult to predict. Good afternoon, thank you. From Alexander, thank you, Alexander. I'm currently working in West Africa, and it has been very interesting to see how the third world has started to catch up with the first world in many areas. However, with machine learning and the way that AI has accelerated over the last 12 months, COVID possibly being the catalyst, do you feel that AI technology will be shared or will fill the gap between first and third world, or will the gap between the first and third world open up again without the chance to even ever catch up? Yeah, it's a good question, Alexander. This kind of democratization in a way of the AI making broadly available. I think that because we are right now, the trend is that a lot of those tools are open source and publicly available. In fact, you know, we even explicitly teach some of them as a part of our courses. So that's fantastic, because that means that developing parts of the world will have immediate access to those open source tools when the internet activities will reach a particular levels. Of course, the question of taking advantage is also whether there will be some computational capabilities that there will be an access. And I think that this is, yeah, that's an open question of how rapidly this will happen. So very, very difficult to say, but I think that the positive sign is the open source community around AI that has really been driving the core trends and revolutions in this space. You know, that there are of course some proprietary AI technologies developed for self-driving cars for some specific purposes, but if you want to use those tools, they are out there, all of them openly available. So that brings a promise that this gap will be bridged. So we have also some questions kind of around, again, the sort of exploitation of data. If the wearables monitor collect most of your body physiology, what is stopping the corporation that own this data from sharing with insurance companies, who in turn use it to decide how much premium you ultimately pay based on the data? Do you believe this encourages unfair and improper usage of such data? There, I think, another one or two questions along similar lines. So, well, of course, you see, it really depends on the companies and when they position themselves. What I found, so last year I was invited actually to give a keynote for one of the insurance company based in London, and I was actually very surprised how distant they are towards this phenomenon and how careful they are in approaching it, because this industry realizes that if they start using this data and the consumers will be, of course, aware of this, there will be a backlash, and they are moving into the space very carefully. You know, there are programs like when you use your Apple Watch, you get some discounts on your insurance premium. For example, there was this program going on for some time, I remember, in London a year or year and a half ago. So they are kind of, I think, testing the surface for the moment, but the principle is that the companies who are collecting this data technically can't share this data with other providers. So from the legal perspective, they shouldn't do this. When they, of course, start doing this, and we find out, I think there will be a backlash, like with the Admiral example. So and companies are trying to be very careful about this. I would. For example, Apple is I would say a good example of quite responsible company that operates in this space. They are very much, they even use the type of algorithms for coding our data, which is sort of based on this reversed privacy algorithms that actually, if they use your data for training any of their own machine learning algorithms to improve their products, which is what a lot of those companies are doing, they do it anonymously, so they don't really know whose data they are using. They just have some baseline indicators around your data. This is called, this is kind of a part of this this way of type of algorithms that they apply. But of course, on the other hand, you have Facebook that actually gives advertisers tools to specify a very narrow, very specific groups of users in targeting for advertising. So here we have a kind of the other side of the profiling. So there will be plenty of discussion around this, but I think that the bottom line is that from the legal perspective, they shouldn't really share our sensitive data, our social media activity. And if it happens, there should be a backlash, and there has been so far in such cases. So I hope that this trend continues, and the governments will also be proactive in trying to implement some regulations around this, similar to what GDPR has been beginning of. Okay, some more questions. Thank you for your insightful lecture. Thank you, Paria. What is your opinion about the public capacity into accepting new technology and eventually for them not being released for public use, including wearable tech? So Paria, again, I might be a bit too optimistic about this because I'm a bit overly optimistic about technology sometimes, maybe. But I think that what we observe is that the society is reacting quite well to the technological innovation. In fact, the adoption of those devices, smartphones and wearables, have been so far quite, quite successful in terms of people sort of bringing it to their lives and basically forgetting about them in a sense. So it's like the use of Google Maps, you don't really think about it anymore. You just set it up to get a direction. But actually, this is a absolutely incredibly transformation technology that really transformed the whole landscape of from supply chain to many other areas, to how we kind of move around the cities. So I would say that acceptability is, I wouldn't see it as a major issue. We can also see that, there is a huge acceptability level in the younger generation, but also because of the accessibility bars going gradually kind of down, the elderly populations are also taking advantage of this technology. So I think that potentially this might not be necessarily the huge issue in the future. Thank you very much, everyone.
I would like to thank everybody who's attending. There's lots and lots of interest, lots and lots of questions. I'd particularly like to thank Lukasz for a fantastic and informative presentation and a real taster of what it's like to attend a class at the university. So I think without further ado, as we are beyond time, I think we can all say farewell, and very good to see you and hope to be in touch sometime soon. Bye for now.